Good afternoon, everybody. Welcome to our session, Botkeeper for Dummies, Demystifying AI or Artificial Intelligence. My name is Byron Patrick. I will be your speaker today. And I will queue up here. There we go. There I am. So brief introduction of myself. I am a Maryland CPA, so I am located here in Maryland. Been here my entire career. I did start with a CPA firm in the early days of my career in the public space and worked my way through a few iterations of my career where eventually I took a left-hand turn into the technology space. So for close to 10 years, I was actually supporting accounting firms with basically the early days of taking their firms into the cloud. 2008, we started moving firms into the cloud. And shortly thereafter, 2013, I was actually the chairman of the Maryland Association of CPAs. With the timing of when that happened, that also happened to coincide with a lot of the cloud initiatives for the Maryland Association. So personally, I've been very involved with technology, the accounting industry, cloud, or just generally technology transformations within the industry, starting with paperless and eventually cloud, and ultimately here with machine learning and artificial intelligence and various levels of automation. I mentioned heavily involved with the Maryland Association. As such, that's also extended into involvement with the AICPA. In fact, I just rolled off AICPA Council, and I'm currently wrapping up my stint on the PCPS committee with the AICPA, among other smaller initiatives. I have been here at Botkeeper for about a year and a half. My role is the VP of Growth and Success here at Botkeeper, which kind of means I'm involved in a lot of aspects of supporting the organization, everything from supporting the sales process to ongoing services and support. So really working with firms day in, day out. I probably talk to, 20 to 30 firms minimum on a weekly basis as we are assisting and working with them to implement automation and machine learning. So all of that being said, I, obviously really enjoy the industry, the profession, and the technology, and really happy to be here with you today to discuss artificial intelligence. So that being said, after that very long-winded introduction, I will jump into our agenda. So the agenda for today, a brief history of AI. I think it's really important as we're exploring artificial intelligence and getting an understanding to take a look back at where we've been, what has gotten us here today, and it'll give us some understanding of, why today, why finally now is it as relevant as it is. We'll jump into, some jargon, we're the actual details of all of this stuff that falls under the term of AI, and make sure from a practical perspective it makes sense. We'll go through some uses of AI. How does that actually apply to certain scenarios and work? And then talk about examples of where AI is being used or could possibly be used in the future within the accounting industry. So pretty jam-packed, definitely a lot to cover here inside of the next 50 minutes or so. Looking forward to taking the journey with all of you here today. So let's jump in. So what is AI or artificial intelligence? Now, you hear a lot of people in the industry, they use a lot of terms interchangeably, AI, ML, and the reality is AI is an umbrella term. I think of AI in the same way that I think of ice cream. We understand what ice cream is, but there's a lot of flavors underneath ice cream. And some would argue vanilla, chocolate, two different worlds. And in some veins, that's also true here with artificial intelligence. So it's an umbrella term that applies to the use of technology to allow computers and machines to operate in an intelligent manner. Now, the intelligent manner part of this is really important. I have heard speakers in the past, I've read articles where people talk about AI being the use of technology to perform human tasks. And if that was all there was to artificial intelligence, that would mean calculators are a form of AI. Calculators are in fact not a form of AI because they're not really operating in an intelligent manner. They are not performing cognitive thought. So, applying cognitive thought to scenarios is what, kind of checks the box and qualifies something as AI. And we'll debate a little bit here in a few slides as to maybe some of these things that people would question whether or not it truly is AI. So you can see in my example here, there's some tentacles that fall off of AI. There's machine learning, which also has a bunch of subtopics: natural language processing, expert systems, vision, speech, planning, robotics. And then below all of these is a whole variety of additional components or sub aspects of these larger topics. So under machine learning, there's deep learning, there's supervised ML, unsupervised ML, and you can see under natural language processing, there's actually a number of subcomponents and so on through the line. So realistically speaking, this image that you see here probably doesn't even get close to including all of the aspects of what is considered AI. It's very much an evolving science and art, some would argue. So this tree is going to continue to grow. But right now, where we're at today, these are probably some of the most relevant aspects of AI. Now, let's take a little bit of a look into the past. What got us here with respect to AI? And it was not called artificial intelligence at the time. But if we look at the history of intelligent machines, certainly Alan Turing in the 1930s created the first Turing machine, which was performing what we would consider to be intelligent processes. And then in the 40s, created the bomb to break the Enigma code. So, this would be the absolute earliest version of what we would consider today to be AI. Now, since the 30s or the 40s, there has actually been a number of AI summers and AI winners. So basically hypes, and then, maybe less enthusiasm for AI over the years. So, again, dating back to the 30s up to the 50s, it really, there wasn't a lot going on, but ultimately, we did have in the 50s leading up to the 60s, the advent of giant computers, these massive size computers that, had vacuum hoses and tubes that were filling entire rooms and actually could perform some level of processing. Now, realistically speaking, our phones now probably have more processing power than all of the giant computers of the 1950s did at the time. But that did lead to some excitement around this idea of intelligent machines. So, the 1960s, there certainly was a peak of interest and excitement, AI summer that ultimately happened. But the reality was we didn't have the computing power at the time to really process the data that we needed. Following the 60s, there was a lot of academic research that was really inspired by a lot of federal funding, DARPA grants, basically to see if there was a way that we could begin to leverage artificial intelligence for our defense systems. That subsequently led to an additional AI summer that led up to about the mid-70s. However, around that time, the government decided to cut off funding for those types of research exercises. And once again, we fell into another AI winter. During that AI winter, we had PCs, Macs PCs, and much cheaper forms of computing. Now, all of a sudden, there's a lot more people who now have access to computing power in their homes, in their offices, and that really inspired another big movement towards, potential artificial intelligence. Once again, funded a lot by government funding, looking for ways to leverage AI and putting the tools in a lot of people's hands. Unfortunately, once again, in the late 80s, a lot of that funding went away. And, also the need for data for it to be successful was still a challenge. Even though now we had better computing power, we didn't necessarily have the data to support any really meaningful AI initiatives. So post the 90s, we had the introduction of the cloud. The internet showed up, and certainly the internet once again created more people able to collaborate, begin using the term artificial intelligence, a lot of research happening, a lot of research documents going on with respect to the possibility of leveraging artificial intelligence. And, there was a lot of excitement around it, but still there was still a missing element that couldn't quite bring everything together. So we did drop into a bit of an AI winter there, but ultimately big data. So now we're in a period of time where data is, we have more data than we can even consume. In fact, just last week, I was having some meetings talking to some folks, and terms like petabytes of data, as if it was just a floppy disk, was pretty normal aspect of the conversation, and that's where we're at right now. So now we have computing power. Now we have access to a lot of data. It really seems like this hype cycle of summers and winters, we are finally in an eternal summer of AI. We now have what appears to be all of the elements to have a really successful run. And if we take a look at the last probably 5 years of AI innovation, I think that certainly reinforced that there's a lot of this coming together, and which brings us here today. Obviously, the accounting industry is certainly being impacted by this, and we should take some time to jump into it, all of these terms and how it fits into the industry. Now, within the scope of AI, there is this concept of general versus narrow AI. And general AI is also acronymed AGI, not to be confused with the tax terms, but artificial general intelligence. So this is the ability to create an AI that actually has the ability to make decisions on its own. Not limited by what programmers have given it, but has the ability to have creativity, if you will. Now, over the years, you've probably seen a lot of movies, The Matrix, Agent Smith, among many others, where AGI has basically, taken over the entire world. It is very threatening. There's a lot of debate as to whether or not we should even be striving towards an actual AGI. But the good news is we are not there yet. We are actually still back at narrow AI. So narrow AI is the application of AI to resolve a very specifically defined task. Now, there are aspects of narrow AI that are beginning to display elements of what we would maybe consider to be creativity, but it really is not creativity in the sense that they have a defined purpose, and the artificial intelligence cannot go beyond that defined purpose. So we are very much in the area of narrow AI, and that is, the place where we are operating. Now, let's jump into some of the terms and make sure we're all on the same page. So natural language processing, NLP, is the acronym that is often used here. This is the ability of, taking spoken words and understanding them based on context, based on speech, and pulling it together to take actions. Now, you would think, for those of us who use words and communicate, that this is fairly obvious and easy, but within the scope of technology, it's not as simple as you would think. And, we do interface with a lot of devices that currently use natural language processing, whether it's going to be OK Google, Cortana, Alexa, there's a number of other elements of where we're using it. But let's think a little bit about the mechanics that go into it. So you might say, set a reminder for tomorrow at 1 p.m. to call dad. Very obvious. We understand what that means. I might say, remind me to call dad at 1 p.m. tomorrow. The computers need to be able to break this down. The technology, you need artificial intelligence to be able to dissect the elements of these phrases and do something with them, take action. So obviously set a reminder or remind me, both mean to set a reminder. Tomorrow at 1 p.m. or at 1 p.m. tomorrow, again, that defines the time in which you are going to execute that action. So set the reminder for 1 p.m. tomorrow. Both sentences are asking for the same thing, but in different ways. And of course, the action is to call dad. So this is a very simple example, but you can certainly imagine how programmers have a challenge to dissect all of the different ways that speech can happen. If you get interested, there's actually some really cool YouTube videos of Google using their natural language processing engine to actually call restaurants and salons to make reservations and actually communicate with the people on the call in a way that the person on the other call actually doesn't even realize they're talking to a computer. Really fascinating stuff, really entertaining as well, to see some of the places where that technology can get tripped up. It's evolving, but a really important element of artificial intelligence. Now, you've probably heard the term RPA quite a bit, robotic process automation. So this is an automation tool leveraging the graphical interface of applications to carry out repetitive tasks. Excuse me one moment. Now, there is debate as to whether or not RPA is actually artificial intelligence. And we'll talk a little bit about that. I'm going to show you an example of what RPA is. But RPA is, I think of it a lot like an Excel macro. If you have ever built Excel macros, you have the macro recorder where you record the steps that you are going to go through that you want Excel to perform for you automatically. And then you hit play and you can actually watch it happen on screen. That is exactly the same as RPA. So as I said, there's some debate as to whether or not that is truly RPA. Natively, RPA in its early days is not artificial intelligence, because all you are simply doing is you are scripting out a bunch of steps to perform. Click here, click there, click these X and Y coordinates, press submit. And basically, if something changes on that screen, the RPA can't follow it. It's broken and it needs to be fixed. That is RPA, which does not include elements of artificial intelligence. Now, RPA has come a long way. RPA has become much more flexible, much more dynamic. If you move one element of the screen, there are tools leveraging artificial intelligence that have been added to make RPA much more robust. Everything from content extraction to image recognition, and other elements of machine learning that are allowing for the RPA to become much more intelligent. That being said, RPA is very much a tool that people use basically to connect applications that can't talk to each other already. You've probably heard the terms API, for example, which application programming interface, the ability to program two applications to talk to each other. If you can build API integrations between applications, you can probably avoid using RPA. RPA is really helpful in the case of legacy systems that are hardened in a way that you cannot connect those together. And, basically you would need a human to sit in the middle to move data between those systems, but you can leverage RPA to do that. I do have a really short video. I, sped it up a little bit, just so, it kind of boiled it down to concise things that we're going to see. But what you're going to see in this video is you are going to see things moving on the screen, and there's not a human driving it. It is happening automatically, and it has to do with the processing of a purchase order. So, you receive information on a purchase order. You need to validate that in your ERP system and ultimately approve that order. That is what you're going to see in this exercise. And you'll see, like, these are certainly some older systems, but you're using Adobe PDF, you're using Salesforce, you're using this CSV file in Excel and pulling it all together. So we'll fire it up and you can see the Excel file at the bottom, the CSV file at the top, and it's validating or pulling the data from the PDF into the CSV file. It's automatically logging into Salesforce with credentials. It will actually perform a search for a quote number, and the system is automatically going to validate that the CSV file, which extracted the data from the CSV from the PDF, matches what is in Salesforce, and then it approved that quote for the next step in the process. All of that happened automatically. Now, you can certainly see where, if various aspects of that process, if something on the screen changes or something gets moved, or maybe Salesforce changes the way in which you log in, that could introduce some challenges for RPA. It's where you can begin to sprinkle in various elements of artificial intelligence in order to make that a more robust and flexible solution. So bottom line is, native RPA, not really AI, but you can certainly enhance RPA. And because it falls under this umbrella of automation, it certainly gets included in a lot of these conversations. Now, machine learning, which I would argue of all of the pieces of artificial intelligence, machine learning is at its core the most important piece, because a lot of these other components of AI have elements of machine learning built into them. Now, machine learning is a method where the target or goal is defined and the steps to reach that target is learned by the machine via training. So you have a bunch of information. The machine learns the patterns, if you will, from that information, and then applies that knowledge to future scenarios. and offers a prediction as to what the outcome should be based on what it knows. So, think about, I tell people all the time, think about if you could remember every single scenario you've ever experienced in your life and recall all of that data, assemble it, and then apply it to every single decision, that would effectively be what machine learning does. The big difference is we can't structure our memories. We can't put them in Excel. That is very much unstructured data. Pure machine learning requires structured data. So there's a few elements that it requires. First, as I said, is data, and that is what we call structured data. So structured data is data that can be organized. You can easily fit that data into a database, into an Excel file, into something where every single item has a very known answer or variable. So with that data, that is what we can build our models on to train the algorithm, which the algorithm is the tool that will actually look at that data and create all these correlations and patterns. I'm going to show you an example of one way in which those models work in a moment, so don't get caught up on that. But bottom line is the machine needs something to learn from, and it needs to learn from structured data. You also have to tell it what the goal is. You need to define what are you going to be predicting at the end of this. You can't just give it a bunch of data to learn from and not program it to understand what it's ultimately going to answer or what predictions the machine learning is going to create. So you have the data, structured data, you have a goal as to define to what prediction you want to make. And then ultimately you have the prediction that comes out of it. Now, the really cool thing about machine learning, at least I think it's cool, is the fact that machine learning will apply a confidence rating. So think about how many times you said, yeah, there's a 90% chance XYZ is going to happen. And that's just based on a swag. You're just coming up with that 90%. Well, the machine learning actually has algorithms that are going to tell you if it says 90%, that is a really solid 90%. If it says 64%, that's a really solid 64%. So that prediction combined with the confidence rating kind of tells us how much we can rely on that information. Now, I mentioned to you we're going to go through an example, and I did a little research to try to find a good example that I felt like, really kind of reinforces the idea or the concept of machine learning. And I found this on a website, r2d3.us. They do a really great job on this website of walking through this example and explaining it. I have boiled it down here to kind of the key points that we will go through, but I highly encourage you after the webinar to check it out. They have some additional information and resources on their website where I think they do a really good job. But suppose we have a scenario where there's a population of houses and we need to determine whether or not those houses are in San Francisco or New York City. This is a hypothetical. Suspend disbelief that you don't know the address. You just know you have a bunch of traits or demographic information about these houses. So because San Francisco is a very hilly town, you might think the elevation of the house is a really great place to begin to separate whether it's a New York City home or a San Francisco home. So by mapping out all of the elevations, and you'll see at the bottom, there's a little arrow that says 91.9 feet. And what that arrow represents is the fault line of where we have the highest percentage of accuracy. So using only one element of the homes, if we choose almost 92 feet, then 82% of the time, we will be correct in deciding whether or not a house is in San Francisco or New York City. And you can see in this chart, where it shows 105 end up in New York City correctly when it's verse 40 in San Francisco, and then 6 in New York incorrectly, 99 incorrectly in San Francisco. So it's not perfect, but it is a beginning point for what we are going to do to create a decision tree. We're all familiar with this idea of a decision tree, if this, then that, and you build it out. Well, one of the machine learning models actually does create a very involved and complicated decision tree. So we know that we need more than just elevation to figure out whether or not those homes are in San Francisco or in New York City. So you can see at the top of this list, elevation. We know the year built, we know how many bathrooms, bedrooms, price, square footage, and price per square foot. In building out our decision tree, because a machine is doing it and can process very quickly, what we can do is we can figure out under those two subsets of data, what the next subset of data should be to get the highest accuracy percentage. So in the case of elevation that is below 92 feet, price is our highest level of confidence for figuring out the next subset of houses, whether they're in which city. And then on the left side, where it's above 92 feet, its price per square foot is actually the better decision point. So that will create the branches of the decision tree. And you can see here at the top is elevation. Depending on where you fall in elevation, it's going to fall to either price or price per square foot. And we can actually keep building additional layers of that decision tree until we can actually get to 100% confidence rating that of our set of model data, we can accurately determine San Francisco or New York City for the location of these homes. And you'll see in here, there's actually multiple branches that are using some of the same demographic data, price per square foot, price per square foot. This decision tree will eventually keep using all of the various demographic points till we end up with absolute 100% coverage in our model. So we might have 200 homes that we are evaluating, and we are going to build this decision tree model that will properly identify all 200 of those homes and which city they exist in. So now that we have the model, we can take this and we can throw a whole bunch of data at it, and you have your decision tree, and you can just take, now you're going to have 500 pieces of data that were not part of that test set of data. This is just data that's been collected that is somewhere out in the ether, and you're going to apply it to our model, and ultimately that will come up with some results. So we can test it. We can put in that data, and we come up to a 90% accuracy rate for that data. Using that, we can now tune the model. Now, there's a whole nother conversation as to, bias and variance and, different elements of how we can tune machine learning models to improve the accuracy of those models, and which is where data scientists are really, really helpful. But this is a really simple explanation for how one aspect of a machine learning model can be built to not only make predictions, but determine the accuracy levels and ultimately the confidence level of those predictions. So that is machine learning. Now, there's another subset of machine learning known as deep learning. Deep learning is the method of analyzing a whole lot of data that is not necessarily structured. So you've probably heard about various exercises where organizations have built deep learning models to play games, to play chess or other strategy games. And all of that data is not necessarily perfectly structured data. It's consuming a whole lot of data and it then making decisions that are going to be different decisions at different moments in time. That is deep learning. Now, deep learning requires a few additional elements beyond just machine learning. First of all, you can't train a deep learning model on 200 homes. A deep learning model is actually going to go out and it is going to study the data of every entire home in the world. It is going to use just an absolute obscene amount of data that, again, is not necessarily structured exactly the same in all jurisdictions, all regions of the world. Deep learning is going to be able to go out and consume all of that data. And it has some freedom. So because it's not necessarily focused directly on your goal is to predict New York City or San Francisco, it has freedom to kind of consume that data and make its own decision trees, if you will, find its own correlations, its own patterns. And ultimately, the outcome of that is we now have an undefined amount of knowledge that we can use. So those deep learning models have consumed all of this data. And now we can begin to leverage that artificial intelligence to make other decisions. Maybe we're going to use that data set to explore power consumption, efficient models of power consumption for homes. Maybe you're doing that one week, maybe the next week it has to do with, property taxes and occupancy, who knows. But because we have this large set of deep learning data, we're actually able to leverage it in a whole lot of different ways. So that is a subset of the machine learning. And now, one last element of artificial intelligence that we're going to talk about today is image recognition. I'm sure a lot of you come in contact with this a lot and probably don't even leverage all of the image recognition that's available to you right now. In preparing for this presentation, I just went on my phone. By the way, I didn't mention in my bio, I own horses. Well, I should say my future wife owns horses. But it makes it really easy to go into my phone and type in horses and bring up a whole bunch of pictures of horses. Type in cats, type in cars. There's a number of things that you can type in where leveraging machine learning models, a whole bunch of data about how you process images. These tools can do image processing. Now, the ability to do image recognition goes way beyond just pictures on your phone. It is used for video feeds. It is used for security purposes. Like I mentioned, it can be used in RPA processes for recognizing images on the screen and knowing when to exercise certain elements of the paths. So image recognition, again, also a very important component of artificial intelligence and really has some aspects of machine learning built into it as well. So as I said, there's many more aspects of artificial intelligence. I would say these are some of the big components of artificial intelligence that we are interacting with or coming in contact with as accountants. And that's probably going to evolve by the time we talk again next year. So let's move into some of the ways in which artificial intelligence is or could be used in the accounting industry here today and into the near future. Now, one element of artificial intelligence is something that I know and understand very well. So I'm going to present it here because it's something that we can really discuss in detail, but transaction categorization. I'm sure all of you, either in your businesses, your personal businesses, your organizations, your firms, you understand the idea of transaction categorization. We have general ledgers, we use QBO, Xero, Dynamics, NetSuite, Intact, whatever the general ledger system may be, and you are consuming a high volume of transactions, that somebody needs to make a decision on those transactions. Now, if you're really familiar with QuickBooks, there are rule sets you can create. And those rule sets have very strictly defined rules. If it says Southwest Airlines, apply it to travel. Perfect, very simple. Except when Southwest Airlines was only an $8 charge for internet, or $6 charge for a drink. So going beyond the rules, the ability to opine on all of the variables associated with that transaction and make a decision on it, and apply some intelligent categorization based on these different elements. You can evaluate it against all the elements of the transaction. So if you are consuming bank feeds, there's a whole bunch of garbage data that comes in through those bank feeds. To most of us, it doesn't always mean anything, but to machine learning algorithms, some of that data, there's actually patterns and knowledge behind it that it can leverage because it remembers everything. And then provide that predictive confidence rating, and ultimately leads to increased accuracy. So in a world where, say, you might have 500 transactions a month that need to be categorized, you might have a certain set of them defined by rules. You hope the rules are accurate, 95% of the time. And then you have another subset of data that you need to apply categorization to. Leveraging machine learning, again, really structured data and a lot of it, you are able to get some predictions of how those transactions should be handled with a confidence rating. And you can make the decision. If it's above 95% confidence rating, I don't even want to see it, done with it. If it's below 95%, I'm going to spend a little more time on it. You can make those decisions once you have that information. But this is a really, really specific way that you can apply machine learning to an exercise that I'm sure all of us on the call today can relate to. So this is one of the tools that we have developed and we've built at Botkeeper, in addition to many other automation technologies, but one that I figured would resonate with you today. Also AI and audit. So I have a lot of good friends and clients who are leveraging various aspects of artificial intelligence associated with their audit process. If you think about the fact that in traditional audit, we can't possibly look at every transaction that ran through the GL. There's just not enough hours, and frankly, it's not an efficient use of our time. But because the machines can actually consume all of that data very quickly and very easily, we have the ability to actually analyze the entire general ledger and look for things that don't necessarily make sense. So rather than the random sampling of, is it ever truly random? There's questions of that. And, are you really looking at the right stuff? Now we can actually make intelligent decisions because the artificial intelligence can actually pick that sampling of maybe the transactions that have the highest likelihood of some sort of abnormality or inconsistency. And now we can test those. Much more precision when it comes to actually executing testing for audits. And then ultimately you could use it for bidding. So wouldn't it be great to be able to, look into the books, run the AI against the books and see just how ugly it looks, and then create a bid that no longer is based on a whole bunch of factors that actually are meaningless, and actually put together a bid that actually has some intelligence, and you really haven't applied that much effort into pulling that together. So artificial intelligence, there's no question, has some really great opportunities to improve the way in which audits are being performed today and tomorrow. The accounts payable process. I would say this is probably one of the steps in the accounting process that can just be absolutely laborious and time consuming. Applying RPA, there are ways, or potentially API integrations, ways that we can actually extract the data from vendor bills and pull out that detail and add it into the accounts payable system. So that alone is a very laborious, time-consuming process, not to mention a process that is riddled with opportunities for mistakes because of fat fingering the steps. So we can improve the accuracy and the speed at which we're doing it. Then leveraging similar machine learning models to what I was referring to earlier when it comes to transaction categorization, to actually apply proper categorization to each of the line items on those vendor bills. And realistically, how many companies are actually taking it to the line item detail for that categorization? This is a way that you could possibly do that. And have all of those line items input into the accounting system very quickly and intelligently and much more effectively. So AI in the accounts payable space, definitely a space that there's a number of players out there, including Botkeeper, who is helping to automate the AI process. A number of other tools that are very narrowly focused on this workflow and creating very robust systems to do it. So this is definitely something that today you can explore. AI and business intelligence. I will tell you, there's been a few iterations that I have seen where folks are trying to implement this. I would say this is still immature. There's more to come. It's definitely evolving. Hopefully this time next year, maybe there will be some more examples of where it is working. But the idea is, if you could say, hey, Alexa, what was our, cost of goods sold for the last 12 months? And just have it spit out to you. And then, hey, Alexa, what opportunities are there to identify the highest costs associated with, XYZ, and have the system actually pull those different variables together. So leveraging natural language processing to assemble those data points and maybe build some dashboards based on that. Like I said, I've seen a number of tools where the concept has been promised. It's been based on a lot of theory and expectations. I've yet to see anybody actually delivering on this in a way that I would say is dependable. But I'm definitely excited for where people are going with it. I think there's really great opportunity here. Another place where I get excited for the opportunity, I think there are definitely some tools out there where this is already being used, but I think it's only the beginning. So, fraud detection obviously is a big concern in anything that has to do with money. And this has some great tools. For example, expense reports. If your organization processes a huge number of expense reports, I know there's been research done as far as determining the number of duplicate reports that come through, potentially the number of duplicate expenses. So if your organization or your client's organization processes a huge amount of expense reports, how do you know that 5 different people aren't all submitting the same dinner receipt? This is a way that AI could potentially cross-reference all that data and find those mistakes and avoid those potential frauds. Same deal with vendor bills. I know, especially for large organizations. In fact, there was a pretty large fraud. I think it was against, I want to say Facebook or Amazon, some large organization where fake vendor bills were being submitted and they were getting paid. So potentially using AI to cross-reference those vendor bills, make sure everything's validated, look for duplicate vendor bills, is definitely an element that could be used. Finally, contract review, and this is really interesting. Again, this is one of those things where I would say it's still a little bit immature, but the idea is you have all of these vendor contracts, and they have different terms, different agreements, different covenants, and it is really difficult to stay on top of all those. By using some form of artificial intelligence, you could potentially scan that in using natural language processing and text extraction, find all of these different rule sets and covenants, and then as bills are coming in, look to make sure that the policies are aligned and potentially flag exceptions that you can then call the attention to the appropriate person to review. So a lot of really great opportunities to leverage this in the fraud detection space when we're dealing with a whole lot of money. So definitely keep your eye out for that. And there's probably another 100 opportunities for artificial intelligence to be used to enrich and expand the ways that we work as humans in the accounting space, which of course I'm super excited about. And if you know of some of those, please, by all means, reach out to me directly. I would love to hear about where you're seeing the application of artificial intelligence working out really well, or maybe not so much. Maybe it's still maturing aspect of it. But all of my contact information is here. If you want to learn more about how we do it at Botkeeper, here's a link to download a copy of a book we recently published, actual Botkeeper for Dummies. We jump into many aspects of artificial intelligence and machine learning. So by all means, reach out, connect. If you hit me up on LinkedIn, let me know that you were on the presentation, so I know you're not a bot. And I look forward to seeing you in cyberspace. With that, thank you all very much for your time today. Have a wonderful rest of the week, and take care.